Hello everyone. Today I'll be finding all the zeros of a polynomial function. Here's my example. To find the zeros of this polynomial function, I have basically two paths that I can follow. Let's take a look at those paths. To find the zeros of a polynomial function, the first question I ask myself is the function factorable? If it is factorable, then I'll go ahead and factor it. And then I'll set each of my factors equal to 0 and solve. And those will produce all the different zeros of the polynomial function. If it's not factorable, then I have to start off by listing all the possible rational zeros. I'll then graph the function using my graphing calculator, and I'll look for the real zeros, the real rational zeros, in the form of the x-intercepts on the graph. I'll use those zeros and synthetic division to reduce my polynomial to a degree 2, a quadratic. The reason I want to get to a quadratic is no matter what quadratic I'm given, I can solve him either by using the quadratic formula, factoring, or maybe using the square root method. Alright, so let's go back and take a look at that function. X to the fourth. Let's see, all the x to the fourths that I've ever factored before used, say, extended quadratic type of factoring or GCF. Looking at all those different terms, I definitely don't have a GCF, and that is not an extended quadratic trinomial. Okay, so then I have to go with the idea of using synthetic division. All right, so the first thing I'm going to do is I'm going to list out all my rational zeros, all the possible rational zeros, by knowing my P over Q. Well, the value of P is negative 18, and the value of Q is 1. Remember, P is the constant in the function, Q is the leading coefficient. All of the factors of negative 18 are positive and negative 1, positive negative 2, positive negative 3, positive negative 6, positive negative 9, and positive and negative 18. All the factors of 1 are just positive and negative 1. I'll divide each of these top factors by the bottom factor to create the list of possible rational zeros. Now again, these are only the possibles. They don't, obviously these are not all of the zeros. Remember, since the degree is 4, I know that I should be producing 4 zeros. This list, positive and negative 1, positive negative 2, positive negative 3, positive negative 6, positive negative 9, and positive negative 18. That list has 1, 2, 3, 4, 5, 6, 12 different possible rational zeros. Way too many than I'm supposed to have. I know I'm only supposed to get 4. Alright, from here I'm going to take that function and I'm going to type that into my graphing calculator. Alright, I look on the graphing calculator, I type it in, I hit graph, and it looks like my zeros would be negative 1 and positive 3, which are definitely in my list of possible rationals, so it seems like I'm on the right track. Just to make sure, a quick way of finding out if those are the actual x-intercepts, I hit second, graph, and I create a table of values. As you can see here, definitely 3, 0, and negative 1, 0. Yep, those are rationals, and those are zeros, so those are two that I can use. All right, so looking at the graph again, I say this value right there, that's a possible 0, and that right there is a 0. And coming over to here, negative 1 comma 0, that's an x-intercept, 3 comma 0, that's an x-intercept. Those are definitely the zeros that I want to use. Now if we think about it again, since I have an x to the fourth, if I found 2 zeros off of the calculator, I can use synthetic division with those zeros once each, and that will reduce my polynomial down to a quadratic, which that I then can solve. So take a look at this. I take the polynomial function, I take either 0, either negative 1 or 3. I'm going to start with negative 1. I put them in the box. I take all of the different coefficients and the constant of my original polynomial. Let's drag this guy down here so that I can see him. And those coefficients would be 1, negative 2, 3, negative 12, and my constant is negative 18. I bring down the 1, and I begin doing synthetic division. Negative 1 times 1 is negative 1. I add, I get negative 3. Negative 1 times negative 3 is 3. 3 plus 3 is 6. 6 times negative 1 is negative 6. Negative 12 and negative 6 is negative 18. Negative 18 times negative 1 is 18. And negative 18 plus 18 is 0. Okay, now since my remainder is 0 when I do synthetic division, that obviously means that negative 1 works, and I've done my work correctly. Now I've reduced this bottom row here. This represents all of the coefficients and the constant of my cubic function. I will now take the other 0 that I got off the calculator, the 3, and I'll do synthetic division on those numbers. 1, negative 3, 6, negative 18. By doing this, I get 1, 3, 0, 0, 6, 18, 0. It works. Okay, now, since I started off with an x to the 4th, and I did synthetic division the first time, as I said, these values underneath the first line represent the coefficients of an x cubed. By doing synthetic division again, this reduces it down to an x squared. So the 1, 0, and 6 represents I've got 1x squared plus 0 x's plus 6. Well, if I set that equal to 0 and I solve, that will tell me I can solve for the other zeros. By subtracting the 6 across, I get x squared equals negative 6. Square rooting both sides, I get x equals, don't forget, whenever you square root both sides, you have to put plus minus as soon as you introduce the radical. The negative comes out as the I, and the square root of 6 doesn't simplify, so it stays square root of 6. So my 4 zeros that this polynomial has is negative 1, 3, positive I root 6, and negative I root 6. And that's how we find the zeros of a polynomial if I can't factor.